Okay, let me give you guys some more practice. So given this distance time graph, work out the distance traveled between 6 seconds and 10 seconds. That's between 6 and 10 here. So work out the distance traveled between 6 seconds and 10 seconds. When you're given a graph, try to inside your mind try to visualize something like try to visualize this. This is your acceleration time graph, and it's a straight line. And then visualize the speed time graph. It will look like that, and then your distance time graph. Have have this inside your mind. So you've got these three graphs here. Which of the three does this graph represent? Well, the distance time graph. So the distance time graph. So inside your mind, you should be visualizing this one here. Now, when you're given this, the area underneath the graph represents the distance traveled. Okay, and when you are here, when you are in the middle graph, the gradient here represents the acceleration. Okay, but you are given this graph here, the distance time graph. So if you want to know the distance traveled, it's going to be a straight reading. So if you want to know the distance traveled, then it's going to be a straight reading, meaning that if this is 7 here, then the distance traveled is 7. Whereas if you're given the speed time graph, the distance traveled will be the area underneath the curve. So it depends on which graph you've been given. So you're given this distance time graph, so you want to do a straight reading. So if you want to know the distance traveled between, let's say, T1 here, and this is T2. Let's say T1 is 3, and T2 is 7. Then it's going to be a straight reading. The distance traveled will be 7 take away 3. Okay, it's a straight reading. Whereas this one here is not a straight reading. You've got to work out the area underneath the graph. Okay, and remember, the gradient of this graph represents the acceleration, and then the gradient of this graph represents the speed. Okay, so just when you're given a graph, visualize these three graphs, and then inside your mind select the position, meaning that which graph are we talking about? We are talking about the third one here. So you are going to do a straight reading, and just remember that the gradient of the distance time graph represents the gradient, the speed. Okay, so here you are given this distance time graph, and remember what that means is it's like you are here, and this is your start. Okay, and you're traveling all the way up here, and this is your finish. Okay, and well, look at this. It takes so you start here. Okay, you start here, and then it takes 3 seconds for you to get to this stage. Okay, so look, it takes you 3 seconds to get to cover the distance of 1, and then you pause, you sit here for 3 seconds. So it's like this. It takes you it's similar to this. 1, 2, 3, and then you got there, and once you got to the 1, then it's like you sitting there for another 3 seconds. Or so let me start again. So it's 1, 2, 3, 4, 5, 6, and then you start moving again, and then 6, and then it takes you 1 second to get to this level here. Okay, so it's like this. Hang on, let me try and simulate it. So you are here. So it takes you 3 seconds to get here, and then you pause for 3 seconds, and then after 3 seconds you would it takes 1 second to get to here, so it's really fast, and then you would have another rest for 3 seconds, and then it takes you another another 7 seconds to get from here to here. So it's going to be like 1, 2, 3, 4, 5, 6, 7, and then you're here. So let me try and simulate that. There's a lot going on, so I will try my best. So you start here. 1, 2, 3, 4, 5, 6, 7, 8. Well, I've miscounted, but when you're, well, it's like, hang on, let me start again. 1, 2, 3, 4, 5, 6. It wasn't very well simulated, but what I was trying to do is from here to here, it takes 3 seconds, and then you would rest for 3 seconds, and then from here to here, it only takes 1 second. It's actually quite hard to simulate if you try and do it yourself. And then once you're here, you would pause for about 3 seconds. 1, 2, 3, and then you would try and get, and then here it would take another 7 seconds. That's this bit here. 7 seconds to get from here to here. Well, anyway, by the way, the speed here is a gradient, which is the height divided by the across. That will represent the gradient. That will represent the speed. So here the speed will be 1 over 3, because the height is 3 and the across, sorry, the height is 1, the across is 3. So it's this. But 3 what? Bananas, oranges, or what? Well, the height is meters. The height is given in meters, and the across is given in seconds. So it's going to be height, which is m, over s. So this the unit of this, a third what? A third meters per second. Okay, and if you want to know the speed here, well, the speed here is the height here divided by this. If you want to know the speed here, well, the speed here, there's no gradient. The speed here is 0. So when you're here, your speed is 0 for 3 seconds. Well, anyway, work out the distance traveled between 6 and 10 seconds. So that's 6 and 10 seconds. So press pause and have a go. Okay, here, if you want to know the distance traveled between 6 and 10 seconds, it's going to be a straight reading. It's not like the speed time graph where you have to work out the area underneath something. Here, because you're dealing with a third graph here, you're going to do a straight reading. So what it means is from here is 1, 2, 3, and then you pause for 3 seconds. Well, anyway, between 6 and 10, it takes you 1 second to get from here to here, and then you're stationary for 3 seconds. 1, 2, 3. So after 10 seconds, you're still here, because it takes you 1 second to get to here, and then you're stationary for 3 seconds. So, well, after 10 seconds, it's just going to be a straight reading. So it's going to be this. Hang on. It's going to be 5, and then 6 is here. So 5 take away 1. So the distance traveled between 6 and 10 seconds, it will be 4. So it will be 4 meters. Okay, because the height here, you're only concerned with the height, which is is measured in meters. So so this equals 4 meters. Okay.